Hello everyone, my name is Fahad Khalid. I am lab engineer here at CISPR. Today I'm going to explain you about the one of the EMCI's testing standard and test how it is performed. In today lab we're gonna do a conducted emission test on device which is in front of you. It is basically a ProStack oscilloscope. I will use this device for the demo purpose of this conducted emission test. Uh, EMC plays very important role in electronic components. It must be every home use or in industry use equipment must be EMCI compliant to be used in a environment. So it cannot harm other devices or other human being around it. So that's why we have must when we have designed the device or for any purpose, we must have to ensure that it is according to the standard defined by the governing bodies. In today's lab, I'm going to test this oscilloscope for the CISPR 32 for class B, so that if someone wants to use this device at his or her home, so that he can, whether it is safe to use it as in home or not, we're gonna check it later. For conducting emission test, we're gonna need the following setup, in which you can see that we're gonna need a EMI receiver, which is basically a spectrum advanced form of spectrum analyzer. It is basically a state-of-the-art equipment. It is of Keysight and it ranges from 1 Hz to 26.5 gigahertz. It has built-in standards and limits, which I'm going to show you later. And to detect the signals on the conducted paths, we're going to need a LISN. LISN basically is a line input stability network. I will explain you in detail when I will explain you in detail about the LISN later. To connect the LISN to the EMI receiver, we're gonna need a RF cable, which will detect the RF signals coming on the input of this conducted lines. As you can see that this device oscilloscope is of single phase, so I have connected this device into the single port of this LISN. Now I will explain you about the functionality of each equipment that is going to be used in this test in detail. Now I will explain you about the LISN functionality. LISN basically is a line impedance stability network. It has the following function. It basically provides a clean source input to the device under test. Basically, if you want to check the device whether it is pre-compliance or not, you have to just check it. You have to make sure that it is not getting any emissions from the port with which it is connected. That's why LISN basically what isolates any noise incoming from the power source. It basically provides a clean power source to the device under test. As in front of you, it is basically a oscilloscope of ProStack, which we're gonna use it for our demo purpose. As I have told you already that it is basically a single phase, that's why I have connected it into the AUT1 of that LISN. AUT2 is basically used for a three-phase devices. As you can see on the screen that there is a line selection button in which we can select the any phase from it. Let's suppose if we are just testing the single phase device, then we will only check it on L1 and neutral. If we are checking the three phase device, then we have to check it on L1, L2 and L3, basically on each three phases and also on neutral. As you can see, there is a test receiver port on it. Basically it's a RF port which is connected directly to the EMI receiver of this spectrum analyzer. This basically captures the emission that is coming on the input lines ports, input lines, basically on L1 and in this case that how much this oscilloscope is radiating on this line L1 and also on N. We're gonna check it through this EMI receiver in front of you. Now I will explain you about the EMI receiver function. Now in front of you is basically a screen extended version of screen of EMI receiver. I have attached a monitor to it so that you can properly see it, how it functions and how it works. Uh, on the screen you can see that this is basically a EMI receiver screen on which you can see, or you can select, or you can edit any option as per your standard. As I have told you before that in today's lab I'm gonna you test this oscilloscope post tag in such a way that if someone wants to work at home with this oscilloscope, whether it is safe to use it in that environment or not. Basically, CISPR is basically European standard. It defines you about the limits. As you can see in the screen, there is a limit line. It is shown here. It basically defines you that whether this device is passes that emission that this device is creating on the conducted lines are below this limit line or not. If this is not the below this limit line, then the device is not be recommended to be used at home. Or if I have selected a class A, which means that this device is used for industry only, then there is some relaxation in the limit. As you know that the device that are going to be used in industry has in industry we have some proper safety and procedures to be followed, so that for that EMCI limit standard for CISPR 32 is class A is little bit relaxed from this class B. So I'm going to test it for the class B for conducted emission to make sure that if I want to use this oscilloscope at home, it is safer to use it or not. Now coming back to the testing for CISPR 32 for conducted emission, I'm gonna have to select this, go to this setting and measurement setup measurement standard. I will select this B for CISPR 32 conducted emissions for class B or class A. The start and stop frequencies are start frequency is 150 kilohertz and stop frequency is 30 megahertz, which is automatically selected by this EMI receiver. If I am using this the spectrum analyzer, then I have to insert the frequency, stop frequency and start frequency like this to myself. And it is state of the art equipment which has built-in functions, so I'm gonna use this. The basic uh, you can say that uh, what we gonna say this basically the overcome or advantage of this EMI receiver is that the signal analyzer we have to check all the option by one, and through with the help of EMI receiver we're gonna do the hours work in just minutes. So it will help in fast processing of this test. It means that the test for the if you're using the spectrum analyzer, you're gonna have to use the post processing also to cater all the responses. I'm gonna explain you how you gonna just click one click including all the options that are available, and you just see on your screen that that device is passing the test or not. Now I will explain you a little bit about the interference of this GUI of this EMI receiver. As you can see that this shows that it will continuously sweep in loops, and this is basically showing the status of the test, whether it is passing or not. If it is passing, that is it will be a green and pass. If it is failing, that it will be a red and fail will be shown on this window. After that you can also add a correction factor to it. Let's suppose, yes, in our case I have told you that with LISN and EMI receiver I'm using this RF cable. I have also cut this RF cable response in correction factor 2 and have turned it on. It means that the losses of RF cable is also been catered here. also has been catered here. And this you have further more option how you can select the standard. It is also a CISPR, and there is how you want to scan type. It will be a time domain, or what type you want to use. Accelerated TDS for higher frequency measurements. It has built-in accelerated TDS which allows you to measure it in seconds. And after that we have this trace cable in which you can select the trace should be of let's if as we are in trace 1, it should be a clear eyed averaging or max hold min hold. You can also this select this. And there is a important button here, detector plays a very important role in our testing. I will When I will explain you about our limits, I have will show you that we're gonna use the quasi peak limits, so that's why I am selecting this quasi peak detector for our testing. As you can see that now Q is appearing here. Now on your right side, as you can see, there is a measurement setup, and there are multiple windows also. Amplitude, bandwidth, you can also select bandwidth, RBW through here, or VBW also. This is basically sorry, I forgot to tell you about the VBW and RBW. This is basically a standard defined VBW and RBW. Once I have selected the standard, it will automatically be change this value to its standard. If you are using the normal spectrum analyzer, you have to input that RBW and VBW by yourself, and also display that what frequency start and stop, which I have already did that for our measurement standard. There are different options to it. I have already selected the quasi peak detector, so I will. You can also detector from here also. There are multiple ways to access the same option. Now coming back to the one of the most important thing, that is a limit line. That what test you are going to perform here. I will go to the limit line and recall form. This basically EMI receiver has built-in limits. I will go to the CISPR 32 and I will select class B conducted quasi peak 150 kilohertz to 30 megahertz. There is also a averaging, but I will select a quasi peak for it. As you can see that a limit line is also appearing on it. For your reference, let me show you about the class A limit line. First, just to know that mostly on this band, that limit line is on say 57 dB microvolt. Let's see the class A limit line. Class A limit line for quasi peak and recall. As you can see that it is way above the class B limit line. It is almost around on 72 or 73 usually on. It means that for the industry equipment there is a relaxation in the limits. As you have already know that in industry we follow the proper protocol for safety and other things, precautions. Now I will go back. I will select the same class B quasi peak and recall it. As you can see that the same limit line which was before is appearing on your screen. Now I will go to the setting. I have told you before that I have selected the L1 on this and the device is in working condition. Just now I will just press this scan button. As you can see that there are some signals appearing on your screen. I will just select this max hold so that white blank. I will go back to the trace 1. I will select max hold. It will max hold the signals that is appearing on it. As you can see that they are very well below the limit line. There are some peaks that may be due to some components inside it, but it is still very inside the limit line for class B. that is basically for home appliances equipments. I will wait for few minutes to check whether there are not any more emissions coming from it on the line 1 of this device DUT, which was basically a Prostack oscilloscope. As you can see that there are still no more any emissions coming from this device at L1. So I will just put this stop sequence button. Now the test is completed at L1 cable. As we can see that there is it is passing the test. It is pass. Trace 1 is pass. Status is pass. And there are some emissions from it, but it is very low as compared to the limit line. Now I will select the neutral. Now selecting the neutral line from LISN. As you can see that it is now shifted to the N, which I have told you before that the oscilloscope that is under test is of a single phase. Now just for that we just only check its L1 and neutral of this device. Now I will shift back to the LISN. Shift back to the EMI receiver. Now I am back on this EMI receiver screen. Now I have will now press this scan button again and check emission on the neutral line. As this is constantly measuring it emissions coming from that neutral line also. The setting will be same. The maximum hold button is on. Quasi peak detector is selected. Same limit line. Start frequency is 150 kHz. Stop frequency is 30 megahertz. RBW VBW same as defined by standard. And the same standard test limit which was for class B home appliances. As you can see that this oscilloscope is also passing on the neutral line. In fact, it has almost a same trend on the neutral line also. The same emission is occurring on the neutral line. It may be because of some components inside it, but they are very below the limit line, so it is passing the test. As you can see that in few minutes you can check whether your device is passing their conducting emission test or not with the help of this EMI receiver, which was basically a advanced form of spectrum analyzer with built-in EMCI standards and all in that. If you are using the basics spectrum analyzer, you have to select or you have to do the post processing in any software, MATLAB or other software. For that you have to cater this limit line. You have to also include the losses of the cables for this test. For the radiated emission test, I will explain you that we were going to use the antenna also. For that antenna we gonna also have to add the antenna factor, which will be explained in next video in radiated emission test. Now I will just stop this sequence. As you can see that there was nothing change in the emissions coming from the oscilloscope which was device under test at neutral line. So this is it for the oscilloscope test. As you can see that it is passing the conducted emission test for CISPR class B. So it is good to be used at home. So the emission that is coming off from it will not harm the devices connected to the same network. That is the emission that is coming from this device at neutral line and phase line are very well below the limit line, so it is safer to use this at home. Now, this was one of the tests of EMCI compliance. For device to be fully compliant, fully EMCI pass device, we have to check its also radiated emission, radiated immunity, and conducted immunity, and all other tests, safety tests, to check whether this device passes the EMC, whether this device is EMCI compliance or not. Now I will test another device, which is ViewSonic monitor. Now, as you can see on your screen, there is a ViewSonic LCD connected to it. Now we're gonna test this device for conducted emission tests with same limits, that is for class B, as we are that the device is good to be used in homes or not. I will follow the same process. I have selected the line, that is also a single phase device, so I have to just check it's on L1 and neutral of this uh, LISN. Now we are back at the screen of EMI receiver. The device now connected to is of ViewSonic monitor, which can be used at home. I will not change the setting. The same setting will be followed. The start frequency will be same 150 kHz. Stop frequency as per standard will be same 30 megahertz. RBW, VPW same value as per standard. Same limit line for class B testing. That was for home appliances, that if you want to use this device for at homes, so you have to check whether it is passing this class B or not. So I will just select this scan and check its emissions. As you can see that it is very much close to the limit line, so we have wait for a few minutes to see if there is any change in signal or emissions coming from the device or not. Now, as you can see that this device, emissions coming from this device at L1 is now way above the limit line. As you can see that now the trace is fail and also the test is fail. It means that this device is not passing the conducted emission test for CISPR 32 class B category devices. I have selected this ViewSonic monitor oscilloscope on purpose, as I would already know that this device has some issue in its PCB. For that demo purposes, I have attached this device to check the emissions from it. It means that in order to use this device at home or an industry, maybe can be passing the industry, but if in order to use this device at home, I have to cater this failing criteria, that what is wrong with its PCB, or we have to diagnose it. So after diagnosing and clearing this test, it will be safer to be used at home. So I will just put this now stop sequence. Now if I want to check that how much it is above the limit line, I will just press this search button. As you can see on the screen that it is now telling me at which frequency it is above the limit line. at 163 and 191 and 260 it is above the limit line, and then how much it is that it, it is almost about zero point 0.9 at 163. At 191 it is around 4.6, which is quite high. So it is not safer to be used at home. That this device is now failing this conducted emission CISPR 32 class B for class B test. uh, I hope now you understand the concept of conducted emission, that how to perform this test, what are the equipment you're gonna need for it, uh, and how you can check it through spectrum analyzer in few minutes that your device is passing this test or not. Now I will just clear this signal list and I will go back to the LISN to select neutral line. Now I will select neutral line from here to check emissions on the neutral line. Now I am back on EMI receiver interface screen. I will just push this scan button. As you can see that on the neutral line at start it is passing this test. Now I'm gonna wait for few seconds to check whether it is fulfilling the criteria or not on neutral line. As you can see that after a few seconds it is above the limit line. It means that it is also failing the test on neutral line, and almost the same trend is following. Now I will just stop this sequence and I will search this. As you can see that it is above the limit line, and it is almost the same but little difference. At 163 kilohertz it is around 1.15 above the limit line. Previously it was 0.9. At 191 it is around 4.6, and 258 it is around 4.4 dB above the limit line. So that's it for today. We will conclude this conducted emission test of two devices. I will now summarize that what we have done in this video. The first was about the introduction about the test setup. Second was about the introduction to which device we are going to test. First we tested the oscilloscope, and secondly we have tested this monitor from ViewSonic which was failing it, and the oscilloscope was passing this conducted emission test for CISPR 32 class B devices. And we have seen it on the EMI receiver that how it is failing the test with that specific band which is defined by standard, and how much it is above the limit line. So that's it for today. Thank you so much. We will back with another video about radiated emissions, radiated immunity and conducted immunities. Thank you.